Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course. General Organic Chemistry. Today we begin with lecture 13 from the course, but make sure you watch the previous ones before viewing this one. So we are discussing the nomenclature of the organic compounds, and in that we are discussing the nomenclature of the organic compounds with functional groups. So in this lecture what we will be discussing is specifically the nomenclature of nitrogen containing organic compounds, where we will be chiefly discussing the amines, alkyl cyanides and isocyanides, nitroalkenes and alkyl nitrites. So we will be starting first of all with the nomenclature of the amines. So the amines, these are the compounds which we obtain by replacing one or more hydrogen atoms of ammonia, that is NH3 molecule, with the alkyl groups. Now ammonia, this has 3 hydrogen atoms. So we can remove 1, 2 or 3 hydrogen atoms and replace them by the alkyl groups, and then we will be getting the amines only. So we will be classifying the amines as primary, secondary or tertiary amines according to the number of hydrogen atoms replaced. If we remove one hydrogen atom and replace it by an alkyl group, the general formula of the compound is going to be RNH2. The compounds, they are going to be classified as primary amines. The functional group therefore is going to be the NH2 group, and the prefix, remember these prefixes for these compounds, these are going to be very important for you people. Okay, so the prefix that we will be using is going to be amino. Okay, the secondary amines, they are going to be having 2 hydrogen atoms being replaced by 2 alkyl groups. The alkyl groups, they may not be the same. Okay, but we will be having 2 alkyl groups instead of 2 hydrogen atoms of the ammonia molecule. So the functional group is going to be this NH group, and the prefix that we will be using for these compounds is going to be N-alkyl amino. Then we have the tertiary amines, where we will be replacing all the 3 hydrogen atoms by the 3 alkyl groups, and the functional group therefore is going to be this N only, and the prefix is going to be the NN dialkyl amino. Where we will be using them, these are the things that you will be learning on later, but these are the things that you have to remember. So the primary amines, these are the compounds where we will be removing one hydrogen atom from the amine, replacing them by the alkyl group. Okay, so when we talk about the aliphatic amines, that means the compounds where they are going to be no cyclic compounds, no aromatic compounds, these will be called as the alkanamines. The IUPAC names, they are derived by adding the suffix amine to the name of the chain or the ring system to which the NH2 group is attached with the elision of the final E. So for example, if we talk only about the aliphatic amines, we will be seeing the name of the corresponding alkane. We will be removing the E from here of the alkane and adding the amine behind that. So these compounds, they can be either straight chain compounds, branch chain compounds, they can be ring compounds, they can be aromatic compounds. So we will be learning about those also very shortly. So the primary amines, for example, if you see over here, we have CH3NH2. So the parent alkane over here, this was CH4, right? So that means methane. So the compound is going to be methenamine. So we have removed the E from here and added the amine to the corresponding alkane's name. Fine. And the common name is going to be methylamine or aminomethane. Remember on the last slide I told you the prefixes. So these prefixes are now going to be helpful for you. So methylamine, that means the alkyl group and the amine behind it, or the prefix that we will be using in front of the name, this becomes aminomethane. Then we have C2H5NH2, and the IUPAC name is going to be ethanamine, again from ethane, ethanamine. And then we have the common name to be ethylamine or aminoethane. Okay, so these common names, they are equally important, so please do remember these also. C3H7NH2, corresponding alkane propane, so this becomes propanamine, the common name being propylamine or aminopropane. So the next are going to be the secondary amines. So these are the compounds where we will be removing two hydrogen atoms from the ammonia molecule, replacing them by the two alkyl groups. So when we are going to name them, they will be named as N-substituted derivatives of primary amines. And what we will be doing is that we will be choosing the parent amine to be the one with the longest carbon chain, and then we will be adding the prefix N as a locant to identify the substituents on the nitrogen atom of the amino group. So you will be understanding this better with the help of a few examples. We have CH3NHCH3. So we have removed two hydrogen atoms, replaced them by two methyl groups over here. Both of them, they are equivalent, so you can consider any one of them to be the parent amine. Okay, so if you supposedly consider this one to be the parent amine, this would have been CH3NH2. So this is going to be named as methenamine. Now we have removed one hydrogen from the methenamine and replaced this by a methyl group. So what you will be doing is that you will be writing this as N-methyl methenamine. So we have added a prefix N, then we are writing the name of the alkyl group that has replaced the hydrogen atom of the parent amine. Okay, so I hope this is clear. Next, we talk about the second example. I will be just coming to the common names separately. So we have C2H5NHCH3. So here your parent amine is going to be the one which has more number of carbon atoms, right? So this is going to be the parent amine. So this is going to be ethenamine, right? And ethenamine, you have removed one hydrogen, replaced it by a methyl group. So this becomes N-methyl ethenamine. The next one is going to have both as the ethyl group, so it is again similar. You can take any one of them. It is going to be ethenamine, and the other part is going to be the ethyl group, which is the N substituted ethyl group. So N-ethyl ethenamine. And when we talk about the common names, well, it is going to be dimethylamine, or it can be N-methylamino-methane. Okay, so just like what you did for the primary amines also, and I told you the prefixes on the first slide while we were talking about the classification of the amines, so that is going to be helpful for the common names. Next we have is this compound C2H5NHCH3. So how are we going to write this as ethyl methyl amine or N-methyl aminoethane, right? And next one is going to be N-diethylamine or N-ethyl aminoethane. Fine. So the next after the primary and the secondary amines, we have the tertiary amines. So what are we going to do over here? We are going to take the ammonia molecule, remove the three hydrogens, replace them by the alkyl groups. So you can see over here in this example, nitrogen. This is a alkyl group number 1, alkyl group number 2 and alkyl group number 3. These may or may not be the same, right? So this is going to be a tertiary amine where we have removed three hydrogen, replaced them by three alkyl groups. And when we are going to name them, we will be naming them as N and di-substituted derivatives of the primary amine. So one of the alkyl group attached to the nitrogen atom, this is going to be the parent amine, and this is going to be the one which will be with the longest carbon chain. And the rest we will be using a prefix NN as a locant to identify the substituents on the nitrogen atom of the amino group, just like we did for the secondary amines as well, right? So when we are going to have three alkyl groups which are going to be the same, one is going to be the parent chain, just like over here we have the CH3, so this is going to be methenamine. And then for the other two, we are going to use the prefix N and dimethyl. Fine, I hope this is clear. So this will be N and dimethyl methenamine. And when we are going to give a common name, it is going to be trimethylamine or N,N-dimethylaminomethanes. So this was the primary amine that we had, and then we have added a prefix for the other groups that were present as the N-N-di substituted groups. Fine. So next you can see over here we have a ethyl group and two methyl groups. So this is going to be ethanamine, where we will be having more number of carbons in the parent chain, right? So this is ethanamine and the rest are going to be N,N-dimethyl. So the name being N,N-dimethyl ethanamine. And when you're going to give the common name, it is going to be ethyl dimethylamine or N,N-dimethylaminoethane. I think now it is clear to you. Similarly, in this example also, if we have two ethyl groups and one methyl group. So now we will be taking again the one which has the more number of carbons. So either you can say this one or this one, it is not going to make a difference. What we will be having the parent amine to be is the ethanamine. Right. Next we have is the ethyl group and the methyl group left. So we will be writing this as N-ethyl, N-methyl ethanamine. E and M, they are according to the alphabetical order. So the common name is going to be diethyl methylamine or N-ethyl N-methyl aminoethane. So the next class of compounds, they are the alkyl cyanides or the nitriles. And these are the compounds which we obtain by replacing one hydrogen atom in the alkane with a cyano group or the nitrile group, which is the CN group. And the general formula for the compounds is going to be CnH2n plus 1, that is for the alkyl group, and to this we have removed one hydrogen from the alkane and replaced this by the Cn group. So here between carbon and nitrogen there is a triple bond. Okay, so the general formula, this can also be written as RC triple bond N. So functional group is going to be the cyanide group Cn. The suffix that we will be using over here for these compounds is going to be nitrile. So the IUPAC name that we will be getting is by adding suffix nitrile to the name of the parent alkane. For example, when the value of N in the alkyl group is 1, we will be getting the cyanide to be CH3CN. And the IUPAC name is going to be ethane nitrile for the two carbon atoms which are present in the compound. So CN group, this already has one carbon, and to this we have a methyl group. So this makes it two carbons, right? So this is going to be ethane nitrile. But when we talk about the common name, it is going to be methyl cyanide. So this group we will be calling as the cyanide group, and this is a methyl group which is attached to it. So this becomes methyl cyanide, and this can also be written as acetonitrile. Then we have N equal to 2, so this becomes C2H5Cn. So again for 3 carbons the alkane is going to be propane. So this becomes propane nitrile, or for the common naming system we will be calling this as ethyl cyanide or propiononitrile. Okay. So now after the alkyl cyanides, we have the next class of compounds to be the alkyl isocyanides or the isonitriles. And these are going to be those compounds we will be getting by replacing the hydrogen atom in the alkane with isocyano group, that is the NC group. And these are going to be isomeric with the alkyl cyanides. How? I'll just now tell you, just a moment. We have the general formula for these compounds to be CnH2n plus 1 NC or RNC. So here you can see and compare these compounds with the alkyl cyanides. What happened in the alkyl cyanides was that the general formula was RCN. So this group was essentially the same, CN. There is one carbon atom, there is one nitrogen atom. In between both of them there is a triple bond. The only difference is that in case of the cyanides, it was the carbon which was bonded to the alkyl group, and now in the isocyanides it is the nitrogen which is bonded to the alkyl group. Okay, so in the cyanides it is going to be RCN, in the isocyanides it is going to be RNC. Fine, I hope I'm clear to you, and that is why they are isomeric with the alkyl cyanides. They will be having the same molecular formula. It is only the point of joining of the group to the alkyl group. Fine. So the functional group for the isocyanides is going to be NC and not CN. When it is going to be CN, it is going to be alkyl cyanide. And the IUPAC names, they are obtained by adding the suffix isocyanide to the name of the alkyl radical present in the molecule. So now if you are going to name these compounds, what you will be seeing is again the value of N, that is the number of carbon atoms in the compound. So now if you are having the N to be 1, it is going to be CH3NC. Now you will not be including this carbon when you are talking about this N. Okay, so it is going to be very important when we are going to name this compound. This carbon is not going to be counted over here. When we had named the cyanides, it was CH3CN, right? So what we had named that compound was ethane nitrile. Okay, we had counted this carbon to be a part of the chain, but now it is not the part of the chain because this is not attached directly to the alkyl group. Fine. So this compound, this will be methyl isocyanide. The common name also being methyl isocyanide. It is also called as methyl carbylamine and is also called as acetoisonitrile. Okay, and then we have N equal to 2. It is going to be CH2H5NC. It will be ethyl isocyanide. The common name also being ethyl isocyanide and ethyl carbylamine. So these compounds, they are also called as carbylamines. The next compounds are the nitroalkenes, and these are obtained by replacing the hydrogen atom in the alkane molecule by the nitro group, which is NO2. So the general formula for the compound is going to be CnH2n plus 1 NO, or we can write this as RNO2, and the functional group NO2 is like this over here. The nitrogen bonded to one oxygen by a double bond, and on the other side it is a coordinate bond between the nitrogen and oxygen. The prefix we have for the nitroalkanes is going to be nitro, and it is always going to be a prefix when we are going to talk about the nitroalkanes. The IUPAC names, they are obtained by adding the word nitro before the name of the parent alkane. So when N is going to be 1, it is going to be CH3NO2. The IUPAC name is going to be nitromethane. The common name is also going to be the same. N equal to 2, C2H5NO2, nitroethane, and the common name also the same. Okay, so easy, I think. For the nitroalkanes, you have not have to remember any other name. One name is going to be the IUPAC as well as the common name. So the next compounds are going to be the alkyl nitrites, and these are going to be the last nitrogen containing compound that we will be discussing. There are two more left after this. One is going to be the girgnard reagents and the other is going to be the sulfonic acid radical that we will be discussing. But as far as the nitrogen containing compounds are concerned, this is going to be the last one. So the alkyl nitrites, these are obtained by replacing a hydrogen atom in the alkane molecule by the nitrite group, and the nitrite group is going to be ONO. So these are going to be isomeric with the nitroalkanes, because in the nitroalkanes also the group was NO2. So it was one nitrogen and two oxygen atoms. Here also we have one nitrogen and two oxygen atoms. The only difference is that here we have the alkyl group attached to the oxygen atom, whereas in the nitroalkanes it was the nitrogen which was attached to the alkyl group. Just like we did the isocyanides and the cyanides, the alkyl nitrites and the nitroalkanes, they are also isomeric. Okay, so only it is the difference in the point of attachment of the group to the alkyl group. So general formula is going to be CnH2n plus 1 ONO, or it is going to be RONO, right? So it is the oxygen atom which is going to be forming the bond with the alkyl group in the alkyl nitrites. So the functional group is going to be ONO, and the IUPAC names, they are obtained by attaching the word nitrite to the name of the alkyl radical in the molecule. So when N is going to be 1, the alkyl nitrite that we will be getting is going to be CH3ONO. So the name is going to be methyl nitrite, the common name also the same. And N equal to 2, CH2H5ONO, it is going to be ethyl nitrite as the IUPAC as well as the common name. The next class of compounds are the Grignard reagents, and these reagents, they are going to be very important when we are going to discuss the various reactions in organic chemistry. Okay, so these reagents, they are alkyl magnesium halides. So they are the compounds of again carbon, hydrogen, magnesium and a halogen atom, and the general formula is going to be CnH2n plus 1 MgX. Okay, this is going to be a really very important compound that you will be seeing repeatedly in your organic reactions. So when we are going to name these compounds, when N is going to be 1, the compound is going to be CH3MgX, and when we have this halogen atom to be chlorine, we will be naming the compound as methyl magnesium chloride, the same common name as well as the IUPAC name. And when N is going to be 2, it is going to be C2H5MgBr. Here we have taken the halogen to be bromine. So this is going to be ethyl magnesium bromide, both the IUPAC as well as the common name. But please do remember, these are going to be very important compounds. So the next class of compounds are going to be the ones which consist of the sulfonic acid group, and the general formula for the compounds is going to be CnH2n plus 1 SO3H or RSO3H. So what have we done? We have taken a alkane, removed a hydrogen atom and replaced it by the SO3H group. So the functional group is going to be this SO3H group, which we know as the sulfonic acid group, and the IUPAC name is given as the alkane sulfonic acid, and the carbon having the SO3H group, this is going to get the lowest possible order of numbering. Okay, so when we are going to have this compound where we will be having this SO3H group, this is going to be sulfonic acid. This is a 3 carbon molecule, so this is going to be propane sulfonic acid, and when this is carbon number 1 to which the sulfonic acid is attached, so this is going to be propane 1 sulfonic acid, and when this group is going to be attached to carbon number 2 of the 4 carbon chain, it is going to be butane 2 sulfonic acid, right? So that would be all for this lecture, and in the next lecture we would be discussing about the alicyclic compounds or the ring structures. Okay, but the ring structures which are not going to be the aromatic compounds. These are going to be the alicyclic compounds which are quite similar in property to the aliphatic compounds. So I hope you like this lecture. We are having a detailed understanding of each and every group, and I hope you are able to remember all these very well, so that when we are going to practice the naming of the compounds, it is going to be very easy for your understanding, because we have had a detailed discussion on all this. So I hope you will be joining me back for the next lecture. In case you have not subscribed to the channel till now, please do that. Just click on the subscribe link, click on the bell icon. You will be getting a notification the moment we put up the next lecture for you. Any doubts that are coming into your mind, please feel free, put them in the comment section. You can also mail them to us at h2chemistry@gmail.com. You can also join us on the Facebook page of the channel by the same name, H2Chemistry. And in fact, that is going to be really beneficial for you, because we keep on posting the questions from previous year exams examinations which are going to be really helpful for you. The students participate in the discussion over there. We are always there to guide you. So I hope you can join us also on the Facebook page of the channel. Thank you and have a nice day. God bless you.